Is this too much? Probably, yeah, but all right, we're doing this. In today's video, we are going to learn the properties of the hyperbola, the formula for the hyperbola, and how to graph a hyperbola using your own pencil, paper, ruler, and all of that, which will be interesting for online learning. So, to review, we have learned about two conic sections so far, the circle and the ellipse. The hyperbola is an intersection of a plane with a double cone, which intersects the double cone twice. So a hyperbola is basically just like an inside-out ellipse, because the hyperbola and the ellipse are graphed a lot in the same way, and you'll notice that their equations are extremely similar. The difference between these equations and the equation for an ellipse is that instead of addition, it is now subtraction. So in the example on the right, you can see that x squared comes first. When x squared comes first, your hyperbola is going to open left and right. When y squared comes first, the hyperbola is going to open up and down. The denominators will not affect this. So it's not like it opens according to the larger denominator. It really is just which one of those comes first. So just like the circle and like the ellipse, HK is your center. So HK is our center here, where we plot the middle of our hyperbola. And then just be careful, because when y squared comes first, it is still HK. You just have to think about getting your h from the x coordinate still. The square root of this denominator will tell us how far to move in the x direction, because it's located under x. So a, you can see here, is labeled on this diagram. The square root of this denominator will tell us how far to move in the vertical direction, because it's located under y. And the same thing here. So in this case, this square root goes with y, and this distance goes with x. So left, right, up, and down. So once you have these two distances from your center, you make points here at your vertices and your co-vertices, and you draw a box. The box has to be in a dotted line. Then you're going to graph your asymptotes. So the asymptotes are diagonal lines that go through the corners of your box. They're also graphed using a dotted line. And then from each vertex, you then draw the branches of your hyperbola, moving close to the asymptotes, but never touching them on either side. You also have a focus. This is a focus and this is a focus. So you have two foci in your hyperbola, just like you did in your ellipse. And the distance to the focus is called C. So from your center to the focus, in order to find C, you need this formula right here. C follows this pattern: c squared equals a squared plus b squared. So basically you add your denominators and then take the square root, and that is the distance from your center to your focus. In a hyperbola that's opening left and right, the focus is going to be along this axis here. This is the transverse axis, the one that the hyperbola is actually located on. The conjugate axis is the other way. You don't have a focus there. So here in our vertical hyperbola, the focus is up and down from the center, but in a horizontal hyperbola, the focus is located left and right. So hopefully you have these notes located somewhere in your binder, and if not, we have placed them into the Google Drive for you to print them. So I'm going to go through a few examples, and I actually want to start with the process of graphing a hyperbola. This is actually a worksheet from the free online resource CUDA software. So if you want to acquire this, you can. It's a good practice sheet, but we also have lots of practice linked for you online as well. So what I'm going to do here is I'm going to build my box and graph my hyperbola, and then identify the vertices and foci. I'm actually going to do the sketch of the graph first. So here I have a hyperbola where x squared comes first. So I know that my hyperbola is going to be opening left and right. I'm going to start by finding my center. So the x does not have parentheses around it, so my x coordinate is 0. I know it doesn't say identify the center, but I want to. So my center is at 0, -1. Because remember, it's the opposite sign from what's in these parentheses. So I'm going to go to 0, -1, and I'm going to put a point there. So in the x direction, I have to take the square root of 20, and in the y direction, I'm going to do the square root of 10. So normally when we are having you simplify radicals, we ask you to change that into a radical in its simplest form. For the purposes of graphing, I do want to get a decimal approximation for this so I can plot this on my grid. So the square root of 20 is approximately 4.5. So I need to go 4.5-ish left and right in the x direction to build my box. So here's 4.5-ish. And 1, 2, 3, 4.5-ish this way. All right, in the y direction, we're moving up and down the square root of 10, which is approximately 3.2. So 3 and a little bit more up each way, up and down. So now, if this were an ellipse, I would just connect and be done, but we are subtracting. It's a hyperbola, so I'm going to use this information to draw my box, fill in my asymptotes, and then graph my branches. So all right, that is acceptable. So here we have our box, and now we're going to fill in our asymptotes by lining up our ruler. You can also think about this in terms of slopes, making sure that you have a consistent slope, but for me, I trust my ruler well enough because honestly, this is just a sketch of a graph anyway. It's not supposed to be perfect. But when we answer things like the location of the foci and the vertices, we can be precise in our answers. All right, so I have my box and it's all in dotted lines, my asymptote also in dotted lines, and now you're going to graph the actual hyperbola itself. When you graph the actual hyperbola itself, you use a solid line. Since x comes first, we're going left and right, and we're gonna hug, we're gonna hug the asymptote, but never cross. Sometimes it's nice to use color to point this out because it's the only part that's actually what you are graphing. Everything else is just a structure that we use to build our graph. So now I'm supposed to identify the vertices and the foci of each. So for my vertices, that is the location of this point here and this point here. They both have the same y coordinate, which is at -1. And for our x coordinate, it's adding and subtracting the simplified version of the square root of 20. So here's a little mini lesson on simplifying radicals if you don't remember how to do that. So the square root of 20 needs to be broken down into its most perfect square parts. So this is the square root of 4 times the square root of 5. The square root of 4 is 2, so it's 2 root 5. So we have positive 2 root 5, -1, and negative 2 root 5. -1. So that is the correct location of our vertices. For our foci, we have to add the denominators and take the square root. So our foci are going to be located at the square root of 30. So 20 plus 10 is 30, the square root of 30. So now I need to simplify the square root of 30. Foci are located at positive and negative square root of 30, -1. Now, if I need to graph these on the grid, I will need to do a decimal approximation. Yeah, that's me just dividing 30 by stuff. Leave me alone. 30, so it's about 5.5. So going out here to about 5.5, that would be the location of this focus and this focus right here. So this is a complete graph with the vertices and the foci labeled. Now, if we wanted to do something else here, then we would need to do this without the graph, and you can picture the graph in your head or just start thinking about what this graph would look like. So for this one, the opening is left, right. You could also call this horizontal. like a horizontal orientation, like we used orientation for ellipses. The vertices are located along the x direction. Since our center is at 0, 0, this is going to be at 9, 0 and negative 9, 0 because it's the square root of 81. And for our foci, 81 plus 4 is 85. So our foci are located this far away from the center, which is at 0, 0. A square root of 85 cannot be simplified. So my foci are at plus or minus the square root of 85, 0. Boom. All right, one last one, just to take you through one more. So this will have a vertical orientation, and we haven't really looked at any hyperbolas yet with a vertical orientation. So for this one, the opening will be up, down, also known as a vertical orientation. The vertices are in the y direction, so they're going to be y coordinates. So from 0, 0, we're going up and down 5. So 0, 5 and 0, negative 5. Then the foci are located even further out from those vertices, up and down, and you add your denominators and take the square root. So the square root of 25 plus 16 is 41, which cannot be simplified. So our foci are going to be located, oh my gosh, 0 plus or minus the square root of 41. So hopefully between our notes, doing some examples without a graph and doing a graphed example together, this has helped you visualize the hyperbola, remember the properties of the hyperbola, think about how to find the foci of the hyperbola, and what all those points mean. So I wish you well on your work this week, and make sure that you check in our office hours to see if you can get some help if you need some more. Have a great day. I'm like honestly already out of breath because I am not used to teaching or even like speaking at all. Cool. So